Hello. 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 Good evening. Good evening. Good evening, Lokesh.
Yes, sir.
Good evening. Happened.
Sir, I can't hear you.
Please check it. Is it audible?
Yes, sir. Sir, I have trouble writing the FRQs.
Which one?
It's like I'm having trouble writing FRQs.
I'm not getting what are you saying?
Sir, means like I'm having trouble writing the FRQs, like the answer.
Okay, okay.
Means like if I do it in rough, I'm getting the answer, sir. But like writing it in the answer format, it's there I'm losing some marks.
Okay, okay. Uh, you have written any paper?
Yeah, sir, I've written from Princeton reviews and also some AP FRQs.
Okay, so
Previously.
do one thing. Just share your script with me. Okay, what you have written, right?
Question and the answers.
And as well as answer. Question is also there, no?
Yes, sir. Questions are also there.
Yeah. So question and answer both you share with me. Okay, na? I
Now,
will check it. Tell me.
now I should send it.
No. After the class, you can send it. Okay.
Okay, sir. Okay.
Then I will check it that where you are losing. Okay, na? And what is the marking pattern? Why you are losing? Okay.
Okay, sir. Thank you, sir.
And then I will. Okay. right? Okay, Charan, you are also writing the questions or not? Hello, Charan. Is it audible? Please check it.
Yes, sir, you're audible.
Okay, let's start. We were in the collision we were about to discuss, isn't it? So, let's continue with the collision part. Okay, right? And what is the condition for momentum conservation? Right, the center mass, acceleration. These are the things we discussed in our last class, right? Okay, and momentum, when we should conserve the momentum. So momentum will be conserved. You can see it here that momentum of a system will remain conserved if the net force acting on the system zero, then momentum will remain conserved. Let's try to understand the collision and why in the collision momentum remains conserved. Okay, so let's continue now. Okay, collision. Okay, so means what here? The two bodies, right? They are moving with different velocity. They are going to collide. So actually, we have bending direction. We have two type of collision. One called 1D collision. It is also called as a one collision, or it is called as the head-on collision. And the other type is 2D collision, or it is called oblique collision. For you, it is mostly the questions will come. We will about the 2D collision and 2D collision and as well as the object. So these two bifurcation of collision is what? Based on the direction of motion. Okay. These two type of collision we written 1D and 2D. That is based the bifurcation. These two bifurcation is what? Based on what is the direction of motion of the particle involved in the collision. Okay. Next, based on the energy lost in the collision process, we have again two type of collision. One is called perfectly elastic collision. Other one is called the inelastic collision. Okay. So these two bifurcation is what? Based
Sir, we
on
can't see your screen, sir.
ba- what you are saying?
Sir, your screen is not visible.
I shared it. Na? Just check it on.
Now it can.
Visible?
Yes, sir, visible.
Check it.
Visible, sir,
Right.
visible.
So based on the direction. So based on direction of motion, based on direction of the particle, two type of collision, 1D and 2D. 1D is called as the head-on collision and 2D is called as the oblique collision. Now, based on the energy lost in the process, okay, again the collision can be written as two way. Okay, it is called perfectly elastic collision. Okay, perfectly elastic collision. Next is partially elastic. Okay, partially elastic, or it is also called as the partially elastic, we can call it, or we can call it inelastic collision. Okay. The third is what? Perfectly inelastic collision. Okay. Perfectly inelastic collision. Okay. So these are the type of collision. These three types are based on the, प्लीज चिल्लाइए मत बाबू, आराम से बैठिए. हाँ आप आराम से. Based any loss in the collision. Okay, based on the energy loss in the collision. Again, we can separate it into different ways. That is called perfectly elastic, perfectly inelastic, and partially elastic or inelastic. It is the same thing. Okay. So now let's discuss about 1D. Just give me a moment. तुम अपना phone देना. Just give me one moment, okay? Let me change the net. I think it's getting disconnected. Is it visible? Check it once. Please check it. Is the screen visible?
Yes, sir.
Right. So let's continue with 1D collision. Okay. 1D collision, and in 1D collision, or you can call it as the uh, head-on collision. Okay. 1D collision and head-on collision are exactly same thing. So in 1D or head-on collision, we will discuss all three types. Okay. So what is the difference between 1D and 2D collision? The 1D and 2D collision, the difference is what? The direction of motion. Okay. Direction of motion of the particle. That is the reason behind we are going to call it as the 1D or 2D collision. Okay. So in 1D collision, what happened? In 1D collision, what happened? That particle motion before and after the collision, it happens along the same line. Let's say this is the particle 1 having mass m1 and velocity u1. And this is the another particle m2 mass and its velocity is u2. This is the situation given to us before collision. Okay, you can see that before collision, m1 mass moving with u1 velocity, m2 mass moving with u2 velocity. After collision, what happened? M1 mass start moving with V1 velocity and M2 mass starts moving with V2 velocity. Can you see that all these velocity of the particle U1, U2, V1, V2, are they all in the same direction? Sorry, not same direction. Are they all in along only one line, right? It may be towards left, it may be towards right. That is not the condition. The condition is what? It should be what? Along the same line. Understood? Before collision and after collision, velocity of the particle involved should be what? Should be along the same line. Please keep in mind, line and direction is different. Same direction means all towards right or all towards left. Same line means what? It can be towards right, it can be towards left. नेट नहीं काम करेगा ना चाहिए. Okay, so it should be what? Same direction. Sorry, it should be what? Along the same line it should be. Okay, understood? So that is the condition of what? Head-on collision. What is the condition? Velocity should be along one line. Unidirection, you can say that. Along a single straight line, you can say that. Okay. Now you see that when these particles will collide, what will happen? Think about it. At the time of collision, what will happen? M1 will experience a normal due to M2, isn't it? And M2 will experience the exactly same normal due to M1. So if you look at these two particles, M1 and M2, can I say that the net force is what? It is 0. And if net force is 0, what does it say? It says the momentum should be what? The conserved. So that's why what happened in a collision, there is no net force acting on the particle. So the net momentum of the system should be what? It should be conserved. Clear? So first equation in any collision is what? First equation we will write it from conservation of linear momentum. Okay, conservation of linear momentum. Conservation of linear momentum says what? Initial momentum. See that m1 u1 you want, you can write it in the vector form also. M2 into u2 vector momentum, m1 into v1 vector plus m2 into v2 vector. So that is the first equation of the collision. What is this equation? Conservation of linear momentum. Second think we are facing some problem with the Zoom. Because of that, it's getting disconnected every time. Okay, let's see. Okay, so first equation we have written the conservation of linear momentum. Second equation is what? It is depending on the type of collision. If it is a perfectly elastic collision, there will be no loss of energy and E will be coming 1. What is E? E is called as coefficient of restitution. E is called as what? Coefficient of restitution. So for perfectly elastic collision, E is 1. For perfectly inelastic collision, E is 0. And if it is a partial elastic, then the value of E will come anything between 0 to 1, depending on what kind of collision we have. Okay. So for perfectly elastic collision, E should be 1. For perfectly inelastic collision, E should be 0. And perfect partially elastic or inelastic collision, the value of E will be 0 to 1. So now the second equation is what? So second equation we will write it is the coefficient of restitution. Okay. And what is the coefficient of restitution? E equal to, it is called velocity of separation. Velocity of separation by velocity of approach. What is coefficient of restitution of a particle or of a collision? It is the ratio of velocity of separation by velocity of approach. So it means if I write it in the mathematical form, what it will come? Separation means what? With what relative velocity they are moving away from each other. So v2 vector minus v1 vector. And with what velocity they are approaching? So that means u1 vector minus u2 vector. So that is my second equation. So in any type of collision, we will always have what? We will always have two equations to solve our variables. And those two equations are what? First equation is momentum conservation. Second equation is what? Second equation is coefficient of restitution. So tell me, there is a special case for perfectly inelastic collision. For perfectly inelastic collision. Inelastic collision. What is E we have? Can I say that for perfectly inelastic collision, E is 0? Means this velocity of separation by velocity of approach, that will become 0. And if that happens, can you say that the velocity of separation is going to be 0? In perfectly inelastic collision, for perfectly inelastic collision, can we say that E is equal to 0? That gives us velocity of separation equal to 0. Velocity of separation equal to 0. Velocity of separation 0 means what? That after collision, V2 and V1 become equal. Understood? What does it mean? It means V2 and V1 become equal. What does it mean? Another way you can say that in a perfectly inelastic collision, after collision, the two particles will stick to each other and move with what? Same velocity. Understood? But it happens only in what kind of collision? It happens only in the perfectly inelastic collision. The velocity of two particles after collision becomes equal to each other. But if it is some other type of collision, then different velocity they will have after the collision. Please tell me, do you understand the two equation of the collision? First equation is conservation of linear momentum. Second equation is coefficient of restitution. Okay. And coefficient of restitution is what? It is the ratio of velocity of separation of the particle by velocity of approach of the particle. Okay. And the special case is what? Perfectly inelastic collision. In a perfectly inelastic collision, after the collision, the two body will stick to each other and they will move with what? They will move with a single body. Move like what? A single body. Because after the collision, both of them will have what? The same velocity. So, can we discuss next part now? Please tell me, clear up to this or not?
Yes, sir, clear.
So let's discuss some examples on 1D collision. Okay. In this example, what is given to us? there is a mass m body and moving with 5 meter per second. There is another mass 2m and that is moving with what? 10 meter per second like this. Okay. Wait. Then the collision is never going to happen, है ना? Because behind body has less velocity. Let's take it 10 meter per second and let's take it 5 meter per second. Okay. They are asking and they are moving along what? Along the same line they are moving. So they are asking in the question, find velocity of both particle. Find velocity of both particle. Okay. Both particle or both body. Particle after collision if E is given as 0.5. Understood? Coefficient of restitution, how much it is given? 0.5. Is it what kind? It is what kind of collision? Perfectly elastic or perfectly inelastic, or it is just partially elastic or partially inelastic, you can say that. Okay. Chaliye, please tell me how much is that coming? How much is coming? The velocity of both the particle?
Sir, V1 is 2.5 and V2 is 10, sir.
V1 2.5 and V2 10.
Yes,
What?
sir.
You must have considered m mass velocity something V1. 2m mass velocity something V2. Okay, so we have to write, we got two variables in the question, isn't it? What are the two variables? The two variables we have, it is the V1 and V2. So we need two equations. First equation, I am going to write it, conservation of linear momentum. What is the conservation of linear momentum? M into plus 10. Keep in mind, it's a momentum going to be written. So we must consider the direction when we are writing. So M into 10. Next, 2m into 5 equal to m into V1 plus 2m into V2. So if you simplify it, m getting cancelled out from everywhere, we are getting V1 plus 2 V2 equal to 10 plus 10, 20. That is our first equation we have. One more equation we have to write it E equal to V2. V2 vector will be plus or minus? So plus, minus. V1 vector, that is also plus, isn't it? Right? V2 vector, V1 vector, these are the vectors we should write it when we are writing the coefficient of restitution. So V2 vector plus minus V1 vector, U1 vector plus 10, U2 vector plus 5. Okay, na? Please keep in mind the direction. And as per the question, how much is that given? Half it is given to us. So we are getting 2V2 minus 2V1 equal to 10 minus 5, 5. Or you can write it, we are getting V2 minus V1 equal to 5 by 2. That is our second equation. Now, if you look at both the equation, we can add both the equation and then we can calculate the V1 and V2. So, if you add equation 1 and 2, what are you getting? So if you add both the equation, V1 get cancelled out, 2V2 plus V2. That becomes 3V2 and 20 plus 5 by 2. So 22.5 we can write it. So V2 we are getting 22.5 by 3. Right. So it is coming 7.5 meter per second, right? And if you put the V2 value, so what is the V1 coming to us? I'm using the equation 1. So if we use the equation 1, so V1 is coming 20 minus 2 into V2. So 20 minus 15, right? So V1 we got it as what? 5 meter per second. Understood? And after calculation, I got V1 and V2 both positive value. What does it mean? It means both are coming what? In the positive direction. Positive direction we have considered is what? The right direction. That means after collision, the velocity of these two particles are what? Towards right. Matlab M mass is moving with 5 meter per second and 2M mass is moving with what? 7.5 meters per second. Understood the question? Please tell me. So two equations we have to use it. Any collision questions you will find out. You will always see there are going to be two equations to solve the question. Understood? Let's discuss the next example. In this example, what is given to us? This is the line of collision. This is also called as line of collision, okay? Line of motion is also called as what? Line of collision. What is the line of collision? Sometimes they will use the word line of collision. Sometimes they will use the word line of impact. Okay. So line of collision or line of impact is what? It is the straight line along which the force between the two particles are acting. Which force is here? It's a normal reaction. Understood? So the line along which that normal force is acting, that line, that straight line is called as the line of impact or line of collision. So in 1D collision, what happened? Line of motion and line of impact are same. Understood? This dotted line, this red color dotted line is what? This red color dotted line, you can also call it, this red color dotted line is line of motion of a particle or line of collision, or it is called as line of impact. Okay. So in 1D collision, what happened? The line of motion and line of collision are same. But when you will see 2D collision question, you will see that that line of motion and line of impact that will come different. Understood? So what is the reason we should find out the line of impact? I will tell you when we will discuss about the 2D collision. 1D collision, there is no problem. It's all same. Impact, line of collision, line of motion, everything is same. Okay. Let's discuss one more example. This M mass is moving with 5 meter per second. This 2M mass is moving in opposite direction with 10 meter per second. Okay. And this time the collision is given perfectly elastic collision. Okay. So they are asking again the same question. Find velocity of each particle. Velocity of each particle after collision. Okay. Understood the question? M mass is moving towards right with 5 meter per second and 2M is moving towards left with 10 meter per second. Find velocity of each particle after collision. After collision, if it is, what kind of collision I am giving in this question? If it is perfectly elastic collision. If it is a perfectly elastic collision, then tell me what is going to be their velocity after a perfect elastic collision. Please tell me what are their velocity, M mass and 2M mass. Okay, for your convenience, I am going to assume it. This is going to be V1 and this is going to be what? V2. Okay, let's assume the M mass will start moving with V1 velocity and 2M will start moving with V2 velocity after the collision between them. Okay. So this is before collision, this is after collision situation in the problem. Okay. Actually, let's one is the momentum conservation Second one is what? Coefficient of restitution. Okay. So please apply these two equations and tell me what is the answer coming to us. Okay, tell me how much is that coming? What is the velocity of each particle coming after the collision? Calculating, write the two equation. Okay, write the two equation. Okay, first write down the conservation of linear momentum. Writing the two equation.
Yes, sir. 1 minute.
Okay.
Sir, is it 5 and 10?
5 and
10.
let's see. Okay. So see, if you are writing like this, first equation, what you will write it? Conservation of linear momentum. M into plus 5, I will write it. Plus 2m into minus 10, we will write it. Please tell me, is it what you have written? Because you are writing, that's what I said. When you are writing the momentum conservation, actually you are writing the momentum. It means a vector quantity. And when you write a vector quantity, you must keep in mind about the direction of the vector quantity. Okay, so m into plus 5, 2m into minus 10. After collision, m mass has v1 velocity towards right. So I have written plus v1. 2m has v2 velocity towards right. So I have written plus. That is the first equation. If I simplify, m, m, m getting cancelled out, we have v1 plus 2v2 equal to minus 20 plus 5. That means minus 15. First equation completed. Now let's go to the second equation. Second equation is coefficient of restitution, E equal to. After collision, see, there is a simple thing about coefficient of restitution. If you are getting confusion in how to write it, always in a collision, decide which is your first and which is your second. Which is your first body, which is your second body. It will be easy for you to write the values then. Okay. So V2 plus V2 है ना minus V1 plus V1 by U1 plus 5 u2 minus 10. Are you clear? Please tell me. v2 minus v1 by u1 minus u2. See that? That's why I have written here the vectors. Check it. v2 vector, v1 vector, u1 vector, u2 vector. Can you see that here? I have written a vector sign over v1, v2, u1,
Yes, sir.
u2. So that we are writing those value in the coefficient of restitution. You must keep in mind about the direction. Okay. And what is given as per the question, this coefficient of restitution. So as per the question, coefficient of restitution is 1 given because it's a perfectly elastic collision. So v2 minus v1 equal to 15 it is coming to us, right? That is the second equation. Now we can add them, isn't it? Let's add 1 and 2. If you add 1 and 2, v1 and v1 got cancelled out. 2v2 plus v2, that is 3v2 equal to 0 coming. So that means v2 is coming 0. What is the v2 coming? v2 is coming 0. And if you put v2 equal to 0 in the equation 1, what are you getting? So v1 plus 2v2 means 0 equal to minus 15. So v1 after calculation, I am getting minus 15 meter per second. Can you tell me what does it mean by these two answers? It means what? After collision, this M1 particle is not moving towards right. Actually, it is moving backward. It is moving towards left. Okay. After collision, can I write the situation after collision? So after collision, if I ask you, this first particle whose mass is m, it is moving in this direction with 15 meter per second, and the other 2m whose velocity I have considered v2, actually that is at rest. Understood? And how did I know that it is moving towards left with 15 meter per second? Because when I calculate the V1, after calculation, I am getting the V1 as negative, right? And in this entire question, I have considered towards right as positive. So if I'm getting after calculation something towards left, I must be getting what as a negative answer. Please shall we clear this one?
Yes, sir.
So this is what the meaning of the perfectly elastic, perfectly inelastic collision. Okay. If it is perfectly inelastic collision, they will have the same velocity after the collision. Okay. So let me discuss two more examples. Now you won't have that much calculation in these two examples, what I'm going to discuss with you. Can you tell me a simple question I'm giving you? 2 kg object is moving with 4 meter per second. Another 3 kg object is there that is moving with 2 meter per second. And they are moving along the same line. They will have the collision as well. And question gave it is a perfectly inelastic collision. Okay, what kind of collision? Perfect inelastic collision. So they are asking in the question, find velocity. Now tell me, if it is a perfectly inelastic collision, can you tell me what will be the velocity of both the particle after the collision? Both particles after collision, are they going to be same? Please tell me, are they going to have same? Here we don't have that much calculation. Can you check it and tell me why we don't have much calculation here? Tell me what will be the velocity of both the blocks? Are both the particle after the collision? So can I say after collision, this 2 kg and 3 kg, both will move with what? The same velocity, right now? You can even consider V1 and V2. But when you will write the coefficient of restitution, V1 and V2 will become same, okay? So can I say here V1, V2 are same. Let's call it V common, right? You can say that common velocity. So it means if I write the momentum conservation, even in that collision, okay, velocity of both particle after collision. After what kind of collision? After perfectly a collision given in the question. Okay, what kind of collision given? Perfectly inelastic collision is given in the question. So let's write the momentum conservation. 2 kg, 4, 3 kg, 2, and 2 plus 3 kg. Both will have same velocity, na? Let's call it that common velocity. So 2 into 4, 6, 3 into 2, sorry, 2 into 4, 8, and 10. 18 by 5. Is it what we are getting? So both will have what velocity? 18 by 5 meter per second. Clear this one?
Question.
Let's take one more example. Okay. In this question, what I'm giving you, mass m is moving with 5 meter per second. Another mass m is moving with 2 meter per second along the same line. Along what? Along the same line. Find velocity of both the ball. Find the velocity of both the ball after perfectly elastic collision. What kind of collision I am considering in this one? Perfectly elastic collision I am considering. Can you tell me what is the answer will come? You want to do the calculation or you want to directly write the answer? You please tell. You want to do the calculation or you want to directly write the answer? Tell me what is the answer coming? Chalo, let me first solve it by the longer method, okay? And then we will learn a direct shortcut here, okay? Okay, tell me. Are you writing the equation?
To directly solve it.
Okay, what is the answer coming? Both are mm only, okay na? So if both are mm only, just to differentiate it, I am writing this as the 1 and this as the 2, okay? So I want to know after collision, what is the velocity of these two? So let's say the first particle has velocity v1, second particle has velocity v2. This v1, v2 I have to calculate. You see, First, I will write the conservation of linear momentum. Okay. M mass, first particle, plus 5. M mass, second particle, minus 2. Okay. M mass, first particle. Okay. This is the first particle. This is the second particle. M mass, V1, plus M mass, V2. Simplify it. M get cancel out. We have V1 plus V2 equal to 5 minus 2, 3. Second equation, coefficient of restitution, E equal to second particle velocity V2 towards right. So I will write it plus V2 minus V1, that is also towards right. So V1. U1 towards right. So plus 5. U2 towards left. So minus 2. And coefficient of restitution as per my question is 1. Because question gave me perfectly elastic collision. So V2 minus V1 I am getting as 7. That is my second equation. Again, let's add 1 and 2. One equation and 2. First and second equation. V1 get cancelled out. We have 2V2 equal to 3 plus 7, 10. So we got it V2 equal to 5 meter per second. And if I put the V2 value in the equation 1, right? If we put the V2 value in the equation 1, we are getting V1 plus 5 equal to 3. So V1 I am getting as 3 minus 5 minus 2 meter per second. That means actually if I write it after collision situation, first particle velocity is left side 2 meter per second and second particle velocity is towards right 5 meter per second. Can you see little bit carefully what is given in the question and what I am getting as my answer? Okay, let me see. Check it. Check the question and check the answer. Can you see any pattern here? Can you tell me any pattern from this question? Look at M1 velocity. Before collision, what is M1 velocity? Towards right 5. After collision, what is M1? What is M2 velocity? Towards right 5. Before collision, second particle velocity towards left 2, and after collision, it's the first particle velocity towards left 2. Can I say that their velocity got interchanged? Please check it and tell me. Means before collision, what was the velocity of 1? That is now after the collision, the velocity of 2. And what was the velocity of second particle before collision? That has become the velocity of first particle after the collision. So can you tell me what is the point I am trying to make here? Can I write a simple point that please keep in mind, perfectly elastic. Keep in mind what kind of collision? In a perfectly elastic collision of two particles. And there is one more condition. It's not the only condition that it should be a perfectly elastic collision. In a perfectly elastic collision of two particles of equal mass. See that? One more important observation. Did I take the particle 1 and 2 both have the same mass? So in a perfectly elastic collision of two particles of equal mass, can you tell me what will happen? After the collision, there, what happened? velocity got interchanged. Understood? Or exchanged, you can say that. Please tell me, understood what we discussed now in today's class? Please tell me.
Yes, sir.
So this is about the 1D collision, 1D, all three type of collision we discussed: perfectly elastic, perfectly inelastic, partially elastic, inelastic, right? And one special case of perfectly elastic collision of two particles of equal mass. So I hope understood now. So tomorrow we will discuss about some 2D collision questions. Okay, we'll try to discuss some questions on the 2D collision. That is not much in the paper, but let's discuss few of the questions on the 2D collision also. Okay.
Okay, sir.
So please tell me, clear? Right.
Yes, sir.
Okay. So let's meet it tomorrow. You can send me your answer script. Okay. I will check it once that what you are doing. Okay.
Okay, sir.
Right.
Sir, can I send it tomorrow morning? Okay, sir. Thank you, sir.
Right. Uh, send it.